Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through firstly the Cartesian plane and then translations. So the Cartesian plane is this diagram here. It's basically two number lines, 1, 2 at right angles to each other. So we call this horizontal number line the x-axis and this vertical number line the y-axis. So these number lines divide the Cartesian plane into 4 quadrants. This is the first quadrant is the top right, second quadrant top left, third quadrant is bottom left, and the fourth quadrant is the bottom right. So where these two number lines meet here is this point called the origin. And at the origin, the x value here is 0 and the y value here is 0. So this is like the middle of the Cartesian plane. So by convention, if we're looking at the x-axis, we go to the right for positive numbers. So this here would be positive 1, positive 2, positive 3, and positive 4. On the left are negative numbers, numbers below 0. So this would be minus 1, minus 2, minus 3, and so on. So now let's look at the y values. Well, the y value is 0 here. So up, we're going into positive numbers. So it goes 1, 2, 3. And down, below 0 are the negative numbers. So this would be minus 1, minus 2, minus 3, and so on. So what we do in the Cartesian plane is we plot points. So I've plotted 2 points here, A and B. They tell us where we are in the Cartesian plane. So points are always written like this. They're always written with brackets and a comma in between. So it's just a convention. The first value is always the x value and the second is always the y value. It's always x first, comma, y value. Whenever you're writing a point, you need these brackets. So if we look at point A, to tell us where A is in the Cartesian plane, we look at the x value and the y value. So from the origin, we've gone to positive 1. That's the x value. And you can see it's in line with positive 3 for the y value. So the way we're going to write the coordinates of A are 1, 3. We always write x first. So this is the x coordinate and this is the y coordinate. A point needs an x coordinate and a y coordinate. So point B here, so if we start the origin, we've gone across to minus 3 is the x value, but we haven't gone up at all. The y value is 0. The y value is 0 at all of the points along here. So the coordinates of B, the x coordinate is minus 3, the y coordinate is 0. So let's say we're given the coordinates of a point here, C, minus 2, 2, and we have to plot it. So remember, the first number is always the x coordinate. That tells you how far you go across from the origin, and the second number is the y coordinate that tells you how far you go up from the origin. So if I want to plot this point C, I start the origin, I go across minus 2 is the x value, and then from there I go up 2 for the y value. This is the location of point C. And there we have it. That's how you plot a point. Now, these arrows on each number line indicate that it goes forever. I mean, you know numbers don't stop at 4. It keeps going 5, 6, 7, 8. But we don't want to draw like all the way up to 1,000. That would take forever. So we just put arrows to indicate that this line goes forever in both directions. This line goes forever in both directions. So that's all for the Cartesian plane. Now, what we're going to start looking at are transformations. When we take a shape and we do something to it. We either translate, rotate, or reflect it. Now we're going to look at translating a shape. So when we translate a shape, we basically just slide the shape. We just move its position. We change the position. We either move it left or right and up and down, but we don't change the size and the shape of the original shape. So what we're going to do here is we're going to look at this shape here. So this is a triangle, and it has obviously 3 vertices. 1, 2, 3. A vertex just means corner. So I'm going to call this triangle ABC. That's how I'm going to name the shape, just naming it by its vertices. So I'm going to translate this shape, triangle ABC, by moving it 3 units to the right and 2 units down. So sometimes we use this vector notation. The first number tells you how much you go left and right because X is first. And then the second number tells you how far you go up or down. Because it's negative, we go down towards the negative numbers. So just be aware, this vector notation for translation has these square brackets, but points have these round brackets. So these are the points of each of the vertices. You see, we can't just move every single point on the triangle 3 right and 2 down. That would take forever. What we're going to do is just take each vertex, each corner, and move it 3 units to the right and 1 unit down. So let's start with point A here. So it has coordinates -1, 3. I'm going to move it 3 units to the right. So 1, 2, 3. It's going to be moved over here. Then I'm going to move it 2 units down. 1, 2. So it's going to move down here to the point 2, 1. So what we do is we call this point here A prime, just A with a dash. So that signifies that this is where A has moved to. A's moved to A dash. So let's do something similar for point B. So point B has coordinates 0, 5, X value 0, Y value 5. I'm going to move it 3 to the right over here and then 2 units down. So it's going to be now at the point 3, 3. And similarly, I put a dash there to indicate this is where B's gone to, B dash. Now I'm going to do the same for the last vertex, the last corner C. I'm going to move it 3 to the right, so it's over here, and then 2 down. So C is going to move to the point 5, 1. So now I know what my shape is going to look like. I can just join up these 3 points. And there we have it. So my drawing isn't perfect on this iPad screen, but if it was, these 2 shapes should be the same shape and the same size. I don't change the shape. I've just changed its position. I've just changed where the shape is located. So this shape, the new shape after translation, is called the image. So we took this original shape and made an image. The image is the same size and shape as the original shape, but it's just in a different position. All right, that's all there is to translations. Thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.